So our first topic is block diagram of communication system. So in block diagram of communication system, we have number of blocks in which there are three main building blocks. They are transmitter, channel and receiver. These three blocks are main building blocks of any communication system. So in this block diagram, there is a source which generates our message signal, information signal, and it is passing through this input transducer. The need of input transducer is, if the source generates non-electrical signal, then this input transducer will convert this non-electrical signal into electrical signal. So this electrical signal will pass through the transmitter, and the transmitter performs some modification in this non-electrical signal. It means that it modifies the original signal in such a way that it can be passed through the channel. So the transmitter performs some modifications in our message signal so that it can be transmitted through the channel, or it is converted into the suitable form which can be transmitted through channel. So this modification is done and it is in such a way that it can be suitable for channel. So this channel can be a wired medium or can be a wireless medium, and after passing through the channel, the signal will be received in the receiver, and what receiver does? Receiver just do the all modification undo. That is, whatever modification we have made in transmitter, all the modification is undo by receiver, and we get our original electrical signal back. Then the output transducer will convert this non-electrical signal into this electrical signal into non-electrical one, and we get our original message signal at the destination. So the process of communication is to transmit the information from source to destination, and for transmitting the signal from source to destination, we have certain process, and that process is explained here. So whatever we perform in transmitter, the reverse operation is done at the receiver, and here we have source which can generate message signal, and the message signal we considered is voice signal, and this voice signal or speech signal is having range 300 Hz to 3400 Hz. This is a voice signal or a speech signal which we consider, and other one is audio signal, and the audio signal is having range 20 Hz to 20 kilohertz, and third message signal which we consider is video signal, which is our information signal, and it is up to 5 megahertz, 4 to 5 megahertz. So these are the message signal which we generate by the source. Okay. Now input transducer converts this non-electrical signal, because if I am saying then this is a non-electrical signal, then it is converted to electrical signal with the help of this transducer. So this electrical signal is passed through the transmitter, which converts the electrical signal into a suitable form which is passed through the channel, and this channel can be of two types, that is wired and wireless. The channel can be of two types, that is wired and wireless. If it is wireless, then there are few examples for wired, that is coaxial cable, twisted pair cable, optical fiber cable, etc. These are few examples of wired medium or wired channel. Wireless can be a free space or underwater transmission. This may be the example of wireless channel. So after passing through this channel, we will receive our signal into a receiver, and we perform undo process which we have done at the transmitter and pass through the output transducer, and this output transducer again converts this electrical signal into non-electrical signal, and we get our original information back. That is one example we can see. That is, if I am saying that my voice is passing through this mic, and the mic here is working as an input transducer. It is converting this non-electrical signal sound wave into electrical signal, and with the help of this wired medium, it is transmitting through the receiver, and now the receiver will convert this signal, electrical signal, into non-electrical signal, and you can listen it from the speaker. So in this way we perform the communication, and we send our message signal from source to destination. Now we are saying that this transmitter does some modification into the signal. What kind of modification it does? So it performs the process called modulation. It performs the process called modulation. So modification, it means it does modulation to the actual signal. So what is modulation? So there are two definitions for modulation. You can write, first definition is, modulation is the process in which low frequency signal is translated into high frequency signal. Low frequency signal is translated into high frequency signal. So modulation is the process in which low frequency signal is translated into high frequency signal, or we can also say it is nothing but the frequency translation process. We are performing the frequency translation. The low frequency signals is translating into high frequency signal. All kind of message signals are considered as low pass signal by default. All the message signals are considered as low pass signal. Now we are translating into a high frequency signal. This low frequency signal, all the message signals which are low pass and low frequency are translated into high frequency signal by modulating the signal. Now the modulation, so this is the one definition which we are saying here, that is the frequency translation process. In frequency translation, we just multiply our low frequency signal into high frequency signal. So we are multiplying here low frequency signal with high frequency signal, and we are getting another high frequency signal. So this is the frequency translation process. This is frequency translation. This is frequency translation. So low frequency signal, which is our message signal. So we are writing here MT as our message signal, and we have high frequency signal. Let us say the high frequency signal is cos 2 pi FCT. Now we are multiplying this low frequency signal with high frequency signal, and we are getting high frequency signal. So how we can prove it that the resultant signal is a high frequency signal? So to prove this, the low frequency signal is translated into high frequency one, we have to consider the frequency of our message signal, and we have to consider some high frequency signal. So we are assuming that the message signal is having low frequency which is 5 kilohertz, and this high frequency signal is having frequency, suppose 1000 kilohertz. Now we have to find the frequency of the output. So we are performing the multiplication here. So we get output y of t. This y of t is equal to mt into cos of 2 pi fct, mt into cos of 2 pi fct. So the spectrum of our message signal, since we know that the message signal is having maximum frequency which is 5 kilohertz, we can draw the spectrum of this message signal by assuming any kind of shape, but it should have the maximum frequency 5 kilohertz. So we are assuming the message signal having a spectrum like this, m of f, and it should have maximum frequency 5 kilohertz, and this is minus 5 kilohertz. We should always remember that this spectrum is having positive frequency as well as negative frequency. All the low frequency signal or the low pass signal should be centered at origin. Now you can see that it is centered about origin, and it should have the maximum frequency 5 kilohertz. So it is measured from only the positive side of a spectrum. So we can say that this signal is having bandwidth 5 kilohertz. So you should remember that if we are talking about the bandwidth of message signal, it means that it should have highest frequency component, that 5 kilohertz. If we are saying that it is having bandwidth 5 kilohertz, then it should have maximum frequency 5 kilohertz, and the spectrum will contain the negative frequency as well, because all the spectrums having positive frequency and negative frequency. So whatever you draw in the positive frequency, the mirror image will be present in the negative frequency. If I draw the positive frequency like this, then there its mirror image will be this, and this will be extended to the minus 5 kilohertz. So this is our low frequency signal, which is 5 kilohertz, and we can also say the message signal having bandwidth 5 kilohertz. So the message signal having bandwidth 5 kilohertz. So if it is given like this, you can draw the figure in this way. Now we are multiplying the mt with cos 2 pi fct. So mt is multiplying with cos 2 pi fct. So what will be the Fourier transform of this signal? So Fourier transform of yt is given by y of f, and it can be written as m of f minus fc plus m of f plus fc, like this. Now we have value of fc which is 1000, so f minus 1000 plus m of f plus 1000. 1 by 2 is the amplitude. If we consider the amplitude here is 1, then whatever will be the amplitude will be half of the original amplitude. Now m of f minus 1000 we can draw. M of f minus 1000, it means that if we equate this argument to 0, then we get f equal to 1000, and if we equate this equal to 0, we get f equal to minus 1000. So what you have to do is, you have to add this 1000 to the whole axis. So if I add 1000, this is 1000 kilohertz, right? So this is 1000 kilohertz. If I add this frequency 1000, then what we will get? So 0 plus 1000, this will be 1000, and 1000 plus 5, 1005, and 1000 minus 5, 995. It means that if we are performing f minus 1000, the signal will shift to 995 to 1005. 995 to 1005, it means that f minus 1000 shifts the original spectrum to the right. Shifts the original spectrum to the right. So we get like this. This is 1000 kilohertz, this is in kilohertz, this is 1005, and this is 995, and the amplitude will become half, because the original amplitude was 1. The original amplitude was 1. So, because of this amplitude 1 by 2, it is now 1 by 2. Now, as you can see that if we add 1000, the signal is shifted to the right. Similarly, if I add minus 1000, why we are adding minus 1000? Because here f is equal to minus 1000. So, if I add minus 1000 in this spectrum, this f axis is added by minus 1000. So, if I add minus 1000 minus 5, minus 1000 minus 5 minus 1005, this is minus 1000 and minus 995. It means that its mirror image. So, its mirror image will be like this. It will shift to this side. So, it is folding itself. Now, we will get like this. This will be minus 1000, and as the negative 995 is here, if I fold this, so this small finger is coming here. So, this is minus 995 obviously, and in this way the value is increasing and this is 0, and in this way value is decreasing. So, this is minus 1005. So, we will get a spectrum like this. Now, as you can see that the resultant signal is having high frequency here, we are saying. So, this yt is having frequency center about 1000. Okay. So, this yt is having frequency center about 1000. Now, previously it was center about 0 and it has maximum frequency 5 kilohertz, and the 5 kilohertz signal is called low frequency signal, and if we multiplied it with high frequency signal, the original signal is centered at 1000 and its maximum frequency is 1005 kilohertz. So, now we can say that this is a high frequency signal. This contains the frequency ranging from 995 to 1005. So, we can say that this is a high frequency signal. High frequency signal, and this is our low frequency signal. And this low frequency signal is centered about origin. That's why it is also called low pass signal. That's why it is also called low pass signal. Low pass signal because its spectrum is centered about origin. If the spectrum is centered other than 0, if the spectrum is centered at other than 0, like in this case it is centered at 1000, it is called band pass signal. Band pass signal. So, it means that the frequency translation also performs the low frequency signal to high frequency as well as the low pass signal into high pass band pass signal. So, after modulation, in modulation low frequency is translated into high frequency and low pass signal into band pass. So, this is the one definition of modulation in which we perform the low frequency signal, or we translate the low frequency signal into high frequency signal, or low pass signal is translated into band pass signal. So, after modulation the signal we get is band pass signal. So, modulation, after modulation we always get a band pass signal, hence the channel should be a band pass channel, and at the transmitter we required always a band pass filter because after modulation signal is converted into band pass signal. So, to get the desired frequency component we use band pass filter at the transmitter. So, this is what first definition of modulation. So, why we are performing this modulation? Because this message signal was having low frequency. So, we can transmit it through the antenna directly. Then why we are performing the frequency translation process? So, next we have to see that what is the basic idea behind this modulation, what is the basic need behind the modulation. So, according to this definition where we are converting this low frequency into high frequency, so why we are converting into high frequency, next will be the topic. So, now we are seeing that the need of modulation. So we are saying that if we have the signal, low frequency signal which is having frequency 5 kilohertz, then why can't we directly transmit through the antenna? So let's see that if we want to transmit the frequency, if we want to transmit the signal which is having frequency 5 kilohertz, then what should be the length of antenna required? So length of antenna is given by lambda by 10. The length of antenna, this is one kind of antenna which is having length lambda by 10, where the lambda is wavelength of the signal to be transmitted. Wavelength of the signal to be transmitted. So now let's see that if we want to transmit the signal having frequency 3 kilohertz, suppose for simplicity I am taking 3 kilohertz, as we have considered the low frequency signal as 5 kilohertz, so you can use 5 kilohertz also, but for the calculation purpose I am taking frequency of the signal which is to be transmitted is 3 kilohertz. So the wavelength is given by C upon F, and the velocity of light is 3 into 10 raised to power 8 and frequency is 3 kilohertz. So 3 into 10 raised to power 3. So now if we calculate this, we get 10 to the power 5, or you can also write 100 kilometer. So 100 kilometer is the wavelength of the signal which is to be transmitted, and the length of antenna will be 100 divided by 10. 100 divided by 10, it means that the 10 kilometer. So we can see that by this example that if we want to transmit a signal having frequency 3 kilohertz, require length of antenna to be 10 kilometer, which is not practically feasible. We cannot install antenna of length 10 kilometer just to transmit a signal which is having frequency 3 kilohertz. Now what we have to do, if we want to reduce the height of antenna, then we should reduce the wavelength of the signal to be transmitted. So we have to reduce the wavelength of the signal to be transmitted, then the length will also be reduced. Now how we can reduce the length of antenna? If I increase the frequency, the wavelength is also reduced. So if we increase the frequency, the wavelength reduces, and let us say the frequency we have translated into 1000 kilohertz, because we have translated our original signal into 1000 kilohertz. As we have seen that in this example, we have translated our original signal around 1000 kilohertz. So if we translate the 3 kilohertz signal into 1000 kilohertz, we have to multiply it by 1000 kilohertz, and this will be the 3 kilohertz signal. So the range will be 997 to 1003. So it does not matter, it is centered about 1000. So if we are taking 1000 kilohertz frequency, then the wavelength will be 3 into 10 raised to power 8, which is the velocity of light, divided by frequency, that means 1000 into 10 raised to power 3, or after solving this we get 300 meter, and the length of antenna now required will be lambda by 10, which is 300 divided by 10, which is equal to 30 meter, which is practically possible, because 30 meter antenna we can think of, but 10 kilometer antenna we will not consider, because this is very huge length, and in compare with this 10 kilometer, the 30 meter is still feasible. And if we increase the frequency further, the length of antenna can reduce more, but practically we will not consider like high frequency, very high frequency like gigahertz, or to reduce just the height of antenna which is installed in the roof, because this antenna here we are using the wireless medium. So it is not like that we are increasing the frequency very much to reduce just the length of antenna, it is not like this, but there should be some high frequency like in megahertz, very high frequency or ultra high frequency we can consider, not in the range of gigahertz. So in this way we reduce the height of antenna, and this is one advantage of modulation. So this is the one process in which we modulated the signal from low frequency to high frequency and take the advantage of this process.